this video, we will look at real numbers in a different way. But first, let's review what we have learned until now. What's the square root of 64? We know it's 8, but how do we get an 8? We write 64 in terms of its prime factors. We write it as square root of 2 times 2 times 2 times 2 times 2 times 2. 6 2's under the square root. To find the square root, we just make groups of two same numbers and choose one from each group. In this case, we can make three groups like this. We choose one number from each group and remove the square root sign. Hence, it will equal 2 times 2 times 2, which equals 8. What about cube root of 64? Doesn't matter if it's a square root or a cube root or the fourth root. The basic concept remains the same. We reduce the base to its prime factors and make groups of as many numbers as the index. So first, we write this as cube root of prime factors of 64. Since the index is 3, we make groups of 3 and choose one number from each group. Hence, this will equal 2 times 2, which equals 4. So this is the basic concept of roots. We reduce the base to its prime factors and make groups based on the index. Now let's understand a few terminologies. Consider 2 raised to 3 or 2 cubed. 2 is called the base and 3 is called the exponent or the power. Here, there's no root. This equals 2 multiplied by 2 multiplied by 2. Now consider the cube root of 8. We see a radical here. The number 3 is called the index or the order. And the number 8 is called the radicand or the base. We will refer to it as the base. This is called the third root of 8. For some reason, many students fear the radical sign. Wouldn't it be better if we can just write this without the radical sign? Since 8 is the base, we can write this as 8 raised to something. But what is that something? Let's see. Cube root of 8 can be written as 8 raised to 1 by 3. So we got this in the base and exponent form without the radical sign. We have 1 by 3 as the power. The power is actually the reciprocal of the index. The index was 3 and the power is 1 by 3. Similarly, the fourth root of 16 can be written as 16 raised to 1 by 4. The index was 4 and without the radical sign, we keep the base same and write the power as reciprocal of the index. And what about root of 256? When the index is not written, it means that's the square root. The index is 2. Hence, this equals 256 raised to 1 by 2. Doesn't matter what the index is. This will always be true. Even the 700th root of 1594 can be written as 1594 raised to 1 by 700. How does this notation help us? Of course, we eliminated the radical sign, but there are plenty more reasons why this notation can really help us. Try solving cube root of 3 multiplied by square root of 3. You would be slightly confused, but let's write it as 3 raised to 1 by 3 multiplied by 3 raised to 1 by 2. This looks comparatively simpler. We know that a raised to m multiplied by a raised to n equals a raised to m plus n. Same base and multiplied, we just add the exponents. So writing it this way makes it easier to use the laws of exponents. Let me ask you another question. Look at these three numbers. 5th root of 6, 4th root of 8 and 6th root of 5.5. Arrange these in descending order. Just by looking at the numbers, you cannot compare them. Writing this in base and exponent form will also help us in comparison of such numbers. We will see how we can compare such irrational numbers in a separate video. So the main takeaway is that the base and the exponent form helps us in using the laws of exponents and in comparison of irrational numbers.